Hey everyone, and welcome back to The Explainer. So today, we're diving into a really massive and honestly kind of urgent topic for, well, pretty much any engineering team dealing with modern systems. We're looking at Chapter 16 of the book Observability Engineering, which is all about telemetry management with pipelines. Now, if you work in observability, security, or platform engineering, you know exactly what I'm talking about here. The massive data explosion. It's everywhere. Every new cluster, every microservice you spin up, they're all just incredibly hungry to emit data. And if you've ever completely dreaded looking at that monthly observability vendor bill, or maybe spent days painstakingly rewriting agent configurations just to add a single new metric, you feel this pain. The traditional way we manage telemetry, it's literally breaking our infrastructure, and it's definitely breaking our budgets. So today, we're going to explore the ultimate structural solution to this whole scaling nightmare. All right, here's our roadmap for today. We'll start with the telemetry scaling problem, then move into the core functions of pipelines, check out the telemetry pipeline architecture, talk about a phased path to adoption, and finally wrap up with the business case. Okay, I want to kick things off with the quote right from the source material. Every signal is critical, or is it? I mean, that perfectly captures the paradox we're living in right now, doesn't it? Modern systems just generate this absolutely overwhelming amount of telemetry. Your observability platforms need performance metrics, your security analytics desperately need audit logs, and your machine learning models, well, they just want everything else. But trying to send everything everywhere all at once, there's just no way. That's completely unsustainable. Low-value telemetry easily buries the data that actually matters. It creates this massive signal-to-noise problem, and the operational overhead of trying to transmit all of it is just crushing teams.
So how do we fix this? Well, we need a telemetry pipeline. Think of it kind of like a power grid. Imagine wiring every single appliance in your house directly to the local power plant. That would be incredibly fragile, really dangerous, and just ridiculously inefficient, right? Instead, we use substations, we use routing, we build in redundancy. All the consumer actually needs is a standardized outlet. Well, telemetry pipelines work the exact same way. Historically, teams will install a dedicated proprietary agent for logs, maybe another one for metrics, and yet another one for security events, all directly onto their application servers. And those agents? They're sitting there competing for CPU and memory with your actual application, sending data over these fragile point-to-point connections directly to specific vendors. The pipeline replaces that whole mess with a central backbone, basically acting as a highly efficient substation for your data.
So let's dive into Section 1, the telemetry scaling problem.
The core of this scaling problem really comes down to the sheer volume of the data explosion. Sending everything everywhere has predictably led to soaring costs. But actually, scratch that. It's the operational overhead that hurts engineering teams the most. Just imagine your VP of engineering suddenly decides the company needs to adopt a new security analytics tool. In a traditional setup, you've got a massive bottleneck. You literally have to touch thousands of hosts, deploy a completely new set of proprietary agents, and just kind of cross your fingers and hope they don't consume too much memory or conflict with the observability agents already running in production. It's a fragile, tightly coupled mess. It turns basic data collection into this month-long, high-risk infrastructure project.
Moving right along to Section 2, core functions of pipelines.
Now, a modern telemetry pipeline isn't just a dumb tube. It's a really sophisticated engine that processes data through a sequence of 5 escalating stages. First up, we collect signals from literally any source. Logs, metrics, traces, you name it. Second, we normalize and secure that data. Raw telemetry is usually a total mess of different formats. So here, we standardize timestamps, enforce schemas, and crucially scrub PII, personally identifiable information, like credit card numbers or emails, before it ever even leaves your network. Third, we enrich the telemetry, and this is absolutely crucial. I mean, a raw error log means nothing if you don't know where it came from, right? The pipeline automatically tags the data with vital business context, like the specific Kubernetes pod ID or AWS region. Fourth, we reduce the volume, really trimming out the noise. And finally, step 5, we route that newly refined telemetry to the exact right destination.
But those 5 core steps don't just exist in a vacuum. They are entirely sandwiched between 2 critical foundational layers. On the bottom, we've got data resilience. Let's face it, analysis backends go down all the time, or network traffic suddenly spikes out of nowhere. This resilience layer uses robust local disk buffering and queuing to absorb those shocks. It ensures you don't drop your critical data during a major outage. Then, on the top, we have pipeline control and observability. This gives you real-time visibility into the pipeline itself. It lets administrators monitor the health of the data flow and instantly push a new redaction rule or routing policy out to thousands of nodes globally, all from one single centralized console.
Which brings us to what's arguably the biggest driver for pipeline adoption in the first place: volume reduction. The reality is, you absolutely do not need to store every single byte of data to have world-class observability. By applying these 4 strategies centrally, you cut massive amounts of waste. We can filter out low-value debug logs entirely. We can deduplicate repeating error messages, like, say, dropping 500 identical firewall denial logs per second down to just one single log with a count attached. We can aggregate raw metrics into higher-level, easily digestible summaries. And, my absolute favorite, we can use intelligent sampling. This is a total game changer. With dynamic sampling, the pipeline can keep 100% of traces that contain an error or high latency, while maybe only keeping 1% of the traces that just show a perfectly normal, fast HTTP response.
Okay, so once the data is normalized, enriched, and heavily reduced, we hit the final step, which is routing. This creates what the chapter calls a fan-out route. Picture this. You have a single, clean stream of telemetry coming in from your infrastructure on the left. The pipeline processes it and then fans it out to multiple highly specific destinations on the right. So you can send critical performance metrics to your APM, your application performance monitoring tool. You can send high-security audit logs directly to your SIEM, your security information and event management platform. And simultaneously, you can dump the whole shebang into a cheap, long-term cloud storage bucket for historical compliance. And you're accomplishing all of this incredible distribution without having to install multiple proprietary agents on your precious application servers. It's brilliant.
All right, let's get into Section 3, Telemetry Pipeline Architecture. At the heart of any enterprise-grade telemetry pipeline, there are 3 core components, and these are built heavily around the Open Telemetry standard. Now, Open Telemetry is this massive, industry-wide open-source project that effectively ended the whole proprietary agent wars. It gave us a universal standard for instrumenting data. Building on that, our first component is the agents. These sit way out at the edge, as close to your application workloads as possible, and they actually do very little processing. Second, we have gateways. These are the centralized, highly scalable nodes that do all the heavy lifting. And finally, we have the control plane, which basically acts as the brain of the entire operation, orchestrating everything from afar. So in a production environment, the data flow strictly follows these roles. The telemetry sources, so your applications and infrastructure, they only ever talk to the agents on the edge. The agents essentially just act as localized buffers that immediately forward the raw data to the gateways in the middle. The gateways are the ones taking on the intense burden of normalization, enrichment, reduction, and routing, ultimately fanning that clean data out to your analysis and storage backends. Meanwhile, the control plane is hovering up top, ensuring every single agent and gateway is functioning correctly. This architectural design is just so smart because it brilliantly decouples the collection of data at the edge from the delivery of data to the final vendor. The really crucial takeaway here is understanding this strict division of labor. You never, ever want to burden your application hosts with heavy data transformation tasks. Think about it. If a logging agent is burning 30% of your CPU just to parse massive JSON files, it's actively harming your application's performance. It's stealing resources from your customers. And, let's be honest, it's probably the thing that's going to page you at 2 a.m. when the server crashes. Agents must stay incredibly lightweight and, well, dumb at the edge. Gateways, on the other hand, run on their own entirely dedicated infrastructure. They are designed to scale horizontally. If a massive burst of traffic hits your system, no problem. You simply spin up more gateways to handle the processing and buffering, completely insulating your application nodes from the impact.
Okay, let's look at Section 4, Phased Path to Adoption.
Now, if migrating your entire infrastructure to a central pipeline sounds completely terrifying, don't worry. The authors of Chapter 16 stress a golden rule. Do not boil the ocean. We start Phase 1 with a greenfield application, so a brand new microservice or an internal tool that's just spinning up. Notice how we leave the existing legacy infrastructure entirely alone. We just deploy the new open standard agent and gateway specifically for this one single new service. This gives your engineering team a perfectly safe, low-risk environment to validate the pipeline end-to-end, test out the control plane features, and really build operational confidence, all without putting any existing critical production flows at risk.
Then we move to Phase 2, which is almost always this massive aha moment for engineering teams. You do not have to rip and replace all your legacy code. Instead, you simply take your existing proprietary legacy agents, the ones already running in production, and you just reconfigure their destination IP address. That's it.
You point their data streams directly to your new pipeline gateway instead of sending them out to the vendor over the internet. By making this one super simple networking change, you instantly gain all the benefits of centralized volume reduction, PII redaction, and compliance routing, all without having to rewrite a single line of instrumentation code in your older applications. It's like magic.
And finally, we reach phase 3. Once the vast majority of your telemetry is flowing smoothly through the pipeline gateways and your team has built up some deep expertise in managing the environment, you systematically start replacing those legacy edge agents with standardized, lightweight, open telemetry agents. This is basically the long-term cleanup phase. Standardizing your entire fleet eliminates immense amounts of technical debt. You unify your infrastructure as code, you drastically reduce the security surface area of running multiple third-party agents, and you create a perfectly homogeneous edge environment that is just infinitely easier to maintain over the next decade.
Which brings us to our final section, Section 5, the business case. We've been pretty deep in the technical weeds here, but let's talk about the ultimate so what for the leaders actually holding the budget. Take a look at this absolutely staggering statistic highlighted in the chapter: 40%. In one detailed case study, a company discovered that up to 40% of the data ingested by their SIEM, their highly expensive security analytics tool, was never actually queried by a human or an alert, not even once. And because observability and security vendors charge by the gigabyte right at the billing meter, that 40% represents literal millions of dollars entirely wasted on processing noise. A pipeline stops that financial bleed before the data ever even leaves your network.
The financial impact of implementing those reduction and routing functions is just enormous. The text shares another case study where a customer utilized a pipeline to selectively drop highly redundant VPC flow logs and filter out all that low-value debug noise. By doing this centrally at the gateway level, they completely eliminated a massive $2.6 million vendor overage fee. Overall, they achieved roughly $2 million in net savings. I mean, pipelines regularly cut overall ingest costs by 50% or more. It transforms an exploding, highly unpredictable line item into a strictly controlled, forecastable budget.
So, a telemetry pipeline fundamentally elevates your data from a financial liability into a strategic asset. You gain predictable costs. You also gain complete vendor neutrality, which Chapter 16 highlights as something that was historically impossible because vendors maintained lock-in through their proprietary edge agents. But when you own the pipeline, you own your data. If you want to switch observability vendors next year, no big deal. You just change a single routing rule in your gateway. You don't even have to touch your edge infrastructure at all. Changing vendors literally takes minutes, not months. And most importantly, you create a unified, perfectly clean data stream that your observability, security, and data science teams can all pull from simultaneously.
Which leaves us with this final question to ask yourself and your team today. Is your telemetry a scaling liability or a strategic asset? The default approach of point-to-point connections, proprietary agents, and paying to store unqueried noise, it's breaking. It's completely breaking under the sheer weight of modern system demands. But by implementing a central telemetry pipeline, you reclaim total control of your data, you radically reduce your costs, and you completely future-proof your systems against whatever new tools the industry invents next. And that is all for today's explainer on Chapter 16 of Observability Engineering. Thank you so much for exploring this with me. I really challenge you to look at your own infrastructure this week and ask where a pipeline might just save your team's sanity and for sure your budget. See you next time.